Hey guys, today we're going to look at problem number 143 in LeetCode, and the problem is called reorder list. So this is the problem. So given a linked list of numbers, the numbers could be 1, 2, 3, 4, 5, 6, 7. So given a linked list of numbers, you need to reorder this list by taking the first element in the list, appending that to the last element in the list, and then you take the second element in the list, append it to the last but previous element in the list, and you keep doing that until you exhaust all the numbers in the list and you reorder it in this order. So this is the problem statement, and how can we approach such a problem? So we need to look at how we tackle this problem while we were trying to understand this problem. So what did we do? We took the first element and then we found what the last element was. How can we find the last element? We need a pointer. We can have a temp pointer and we keep moving the pointer all the way until we find the last element. The last element is an element whose next points to null. We take the last element, we append it here, and then we link it to the second element, and then we keep moving all the way until we find the next last element. And to find this, you should have removed this last element from this linked list, and so we can keep doing the same thing, and we would finally converge, we would finally get our answer. And this is a brute force solution, and is this the most optimal solution? It doesn't seem so, right? Because you kept moving through your list, you kept iterating through your list multiple times to find the last element in the list, and so that makes it not the most optimal solution. And we ask this question: what could be the most optimal solution to this problem? So now we need to put on our data structures and algorithms hat. Let's say we have these numbers, and how can we approach this problem in the most optimal way? How can we reorder this list in the most optimal way? So when we try to do it in the brute force fashion, we were trying to iterate through this list just to find the last element in the list, and when we appended that, we wanted to find the last but previous element in the list, linked list. So what is a data structure that when you introduce all the elements in the linked list, 1 2 3 4 5 6 7 8, so 9, let's say this is your data structure. What is the data structure? When you ask it to give the first element, it gives it in O of 1 time, and you ask it to give the last element, it gives it in O of 1 time, and it's easy to remove the last element from that data structure. My brain immediately thinks of a stack to do this part, right? A stack can do this. You continuously stack these numbers in the stack, and you can access the top element, or which is going to be the last element in your stack. And what is a data structure that gives you the first element in the stack? It can again be another stack where you pop all these elements from your stack and you can put it in another stack, which is just 1 2 3 4 5 6 7 8 9, and you can access the top element in your stack. Or it could just be a queue, right? A queue can be 4 5 6 blah blah blah. It can have, you can store all these numbers in a queue where the front of your queue points to the first element in your array. So nice. Let's look at how we can use this concept of stacks and queues to solve this problem. So I need to iterate through all the elements in this linked list, and while iterating, I'm going to store it in these two data structures. So I'm going to have a stack, and I'm going to parallelly store these elements in a queue. So I have a stack, I have a queue. The stack is used to store find the last element. The queue is used to find the current element. So I encounter 1, I store it in both the stack and queue. I encounter 2, store it both in stack and queue. 3, 4, 5, so on and so forth. So when you ask the stack for the top element, it's going to give you 5. When you ask the queue for the front element, it's going to return 1, because that's how we define stacks and queues. So it's a data structure. Stack is last in first out, and queue is first in first out. That's how they work. So how can we create this? So given our numbers were 1, 2, 3, 4, 5, I need to reorder this into 1, 5, 2, 4 and 3. So how can I reorder this? I take the top element in the queue or the front element in the queue and I append it to the top of the stack. Great. And now I no longer need to care about 1 and 5 because I've covered 1 and 5 in my list. So I pop these two elements in my stack and queue, and the front in the queue moves to 2 and the top in the stack moves to 4. I append the previous value to 2 and I append the value of the queue to the value of the stack, which is 4, and I no need to care about 2 and 4. And I keep doing the same thing. I take an element from the queue and I append it to an element from the stack, and now you see that this is something wrong, right? 3 is a pointer in memory, 3 is another pointer in memory, and I can't, this is not a right operation. I just need to stop with this 3 and I need to point this 3 to null. So we check this termination condition and we end our program. So that's how it works. This is I think this is the most optimal way to approach this problem, and you saw my thought flow, how I initially started with a brute force solution, and then I saw what was repeating unnecessarily in my brute force solution, and if I could trade off the computational complexity with by storing some elements in the memory, and this we saw how our thought process led us to using stacks and queues, and we saw a simple implementation of how we could tackle this problem using stacks and queues. So you go on, try to solve this problem in LeetCode. If you have questions, you just post it in the comment section. Thank you.